Hello guys, welcome to topic 11. This is clipping and windowing. Now understand that when we are talking about windowing and clipping, we need to have a window. We talk of a window in a world of coordinate system. Within this window is where we will display our content. There could be objects that lie within the window or portions of an object that lie outside the window. And this is where the idea or the concept of clipping comes into play. In this tutorial, we're going to concern ourselves with line clipping, and we have three different types of lines. We have lines that are visible, lines that are invisible, and lines that will require clipping. A visible line, as shown in this case, we have several cases. A visible line would be line that would lie within the window, as shown in case 1. We have lines that are within the window, and our window is in blue. Case number 2 shows us invisible lines, and these are basically the lines that lie outside the window, and we do not need to concern ourselves with those lines. Case number 3, we have lines that do require clipping, and these are the lines that partially do lie within the window. If you look at the two lines that we have here, they need to be clipped. You can see we need clipping at P1, we need a clipping at P2 here. Case number 4 shows us mixed lines. Basically, the lines we have just talked about. CD is within the window. Line AB is partially within the window, so requires a clipping here. Line EF is outside the window, and we do not need to concern ourselves with that line. We have different applications of clipping. We could use clipping if we want to extract parts of an object or line that we desire, for identifying the visible and invisible areas in the 3D objects, for creating objects using solid modeling, for drawing operations. We have operations related to pointing of an object, and lastly, we have deleting, copying, moving parts of an object. Like I've said, we are concerned with line clipping. However, we do have other types of clipping, such as point clipping, area clipping, curve clipping, text clipping, and exterior clipping. We are going to use Cohen Sutherland Algorithm in computer graphics. Is used for line clipping. The algorithm basically is an old algorithm that will speed up the process of line segment by performing initial tests that would reduce number of instructions. So each section is assigned a 4-bit binary code when we do divide the two-dimensional space into 9 regions. And then efficiently, we have to determine the lines and portions of lines that are visible in the central region of interest, and that is our window. Now, for us to be able to work with the 9 regions, what we do, we assign each region a 4-bit code, where T represents the first code, B second code, R the third code, and L the last, that is the fourth code. So the initial TBRL represents the 4 bits. Now these are the 9 regions that we are talking about. If you look at this region here, region 1, the code that has been assigned to this region is 1001. Why is it that we have 1001? Now if you look at T, this region is at the top, therefore we assign a 1. This region is not at the bottom, we assign a 0. It's not on the right side, so we assign another 0. Is it on the left side? Yes, it is on the left side, and therefore we assign a 1. Region number 2 is only at the top. Neither is not at the bottom, not at the right, not at the left, and therefore we assign just a 1 for the top, and then the rest is 0. This is the area of interest here, region number 5, and it is assigned a 4-bit code, 000. Now, if you look at region number 8 is at the bottom, and it is not on the left, neither is it on the right, and therefore what do? We assign a 1 for the bottom, leaving us with code 0100. The same applies for all other regions except this region. So use the same procedure for getting the codes for each and every one of these regions. Now, once we determine the region code of each endpoint of a line, we can find out whether the line completely lies outside the clipping window, or the line completely lies inside the clipping window, or the line partially lies inside the clipping window. Now, we basically use the logical AND, where we are saying 1 and 0 gives us a 0, 1 and 1 will give us a 1, 0 and 1 will give us a 0, and 0 and 0 will give us a 0. It is as simple as that. Now let's look at these examples. We have several lines here in our 9 regions. Remember, the numbering was region 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if you look at P1, P2 here, the code assigned to that region is 0001. Again, if you look at P5, P6, partially lies within the window. P3, P4 within the window. P7, P8 partially also lies within the window, this segment here. Therefore, what we need to do, we need to discard the segments that lie outside the window. They need to be discarded. Now, we can use the AND operation for us to be able to know whether a line actually lies outside or within the window, or partially within the window, as shown here. P1, P2, 0001 and 0001 will give us 0001, because 1 and 1 gives us a 1. That's the reason why we have a 1 here. So we're saying they are used, the line is outside the window. Now, P3, P4 tells us that the line is within the window. P5, P6 tells us that the line partially lies within the window, and therefore that line would require clipping, as shown here. You can clip this segment where we have P5 to P5 dash can be clipped so that we can remain with P5 dash and P6. So that segment is what we are concerned with. Now, we need an example for us to be able to understand exactly how the operation works. So let's take an example where we have a rectangle A, B, C, D. That being our window, where the coordinates are: for A we have 2, 2, B we have 9, 2, C we have 9, 7, D we have 2, 7. So using Cohen Sutherland line clipping algorithm to clip line P1, P2, where P1 coordinates are 1, 3, P2 coordinates are 8, 9, and line R1, R2 coordinates are R1, 1, 1, R2, 7, 6. Now here is the diagram that shows us the window is there. So a rectangle, so a window, and then we have 2 lines, the blue line and the orange line. The blue line from this segment here is outside. And we can see this other segment here is outside. That is P2 dash and P2 is outside. P1 dash, P2 dash is within the window. P1 and P1 dash is outside the window. Same applies for our line R1, R2. R1 and R1 dash is outside the window. So we need these segments that are within the window. Now for us to clip, must remember the region mapping, region 1 to region 9. As we have seen here, P1 and P2, P1 lies in region 4, P2 lies in region 2. And these are the 4-bit binary codes. If we do the AND operation, we get 000. This tells us that this line is partially within the window. Now, if we come back again, we can tell, if we look at P1 dash, we can be able to tell that its X coordinate will be 2. If you look at P2 dash, you can tell its Y coordinate will be 7. We do not know the X value for P2 dash, and we also do not know the value for the y-axis for P1 dash. We need to work with a slope if we are going to, we need to get the slope of that line if we are going to get those values that we do not know. Like if you look at P1, P2, that line, how do we get the slope of that line? It's basically delta y, delta x. That is the difference in y-axis and the difference in x-axis for those lines. And if we substitute those values, we'll be able to get 6, 7 as the slope. Now we can use that slope for the segment for us to be able to get these coordinates for this particular segment that we are interested in, because any segment of this line would have the same slope value. Now, P1 dash coordinates are here 2. We know this is the x-axis 2, so we have 2, and then the y-axis, the value in the y-axis we do not know, so we need to find it. So we know the x-axis coordinate of P1 is value 2. So we compute the y as by basically substituting the computations for the slope. And once we substitute, we end up getting 3.86. Therefore, the coordinates for P1 are 2, 3.9. Now, if you look at line the other end where we have P2, we also need to get its y coordinate. We know its y coordinate, and therefore we need to get its x coordinate. We know the y coordinate is 7. So how do we get the x, the coordinate for the x? The x value we do not know. So again, we substitute as we have done before, and we end up arriving at the value 5.7. So the coordinates of P2 dash are 5.7, 7. 5.7 is our x, and 7 is the y-axis value. So basically, using the same operations, I'm sure you can be able to compute the slope for R1, R2, and then you can be able to proceed and clip the segment of the line that lies outside the window, so that we can be left with the segment that lies within the window. Good luck with that. It's very easy, and I know you're going to get it right. Thank you.